Okay, we're going to look at algebra expanding and factorising. So I'll kind of start from the beginning, but remember we have learnt this multiple times this year. Let's start with number. So if I go 3 times 5, that's the same as 3 times 2 plus 3. Is that okay? Okay. It's okay because 2 plus 3 is 5. Okay? So we've always learnt with bed maths that you've got to do brackets first. Okay? But in a way, you don't have to. Because you can do a trick. You could replace this with 3 times 2 plus 3 times 3. So what you've actually done is you've said I've got 3 times 2 plus 3 times 3. What does that look like? It looks like here's my 3 and here's my 5. So I'm going to draw it like that. I've got 3 this way and I've got 5 that way. Is that okay? So what I've done is 3 lots of 5 is the same as 2 lots of 3. That's my 2 lots of 3. And here's my 3 lots of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that making any sense? Because it's really important that you get it with number. So what I'm saying is that this is 3 times 2 and this is 3 times 3 because this is 2 and that is 3 and 2 plus 3 is 5. Does that make sense? Okay, so let's just have a look at that again another kind of a way. What I've said is, if I've got 2 times 2 plus 3, that's the same as 2 times 2 plus 2 times 3. So that's an interchangeable statement. This is called factorised, that's called expanded. So when you're going like that, that's called expanding. And you're going like that, that's called factoring. Does that make sense? Let's have a look at another one, see if you've got the idea. So I'm going to go 3, 2 plus 5. What's that the same as? 3 times 2 plus 3 times 5. Okay. So what you've done there is you've expanded. Okay, so it's kind of not bed maths anymore, because if you were doing bed maths, you'd go 2 plus 5 is 7, and 7 3s are 21. But here we go 3 times 2 is 6, plus 3 times 5, which is 15, and 15 plus 6 is also 21. The general, I love that sound, the general idea is any number plus any numbers there, that's AB plus AC. Now, so what algebra is, this algebraic rule, where if you go this way, you are expanding, and if you go this way, you're factorising. That's actually called the distributive law. And it's a rule that applies for all numbers. It doesn't matter what A is and B is and C is, it will always work. So if I went 3, 8 plus 12, that would be the same as 3 times 8 plus 3 times 12. So I know that those are equivalent expressions. I know they are the same. I know that this side equals that side. So I can think of it as length A there, length B there, and length C there, and saying that this length is B plus C. So here, A times B plus C is going to be that big triangle, okay? Or I could work out A times B, and I can work out A times C, and then I add them together. But it won't change that area. Okay, so you can think of it as generalized number, you can think of it kind of as a measurement thing, but you can also think of it as the distributive law that I'm applying. So let's try some where it's important that we know this rule, because we can't do the brackets first, because inside the brackets there's an x. So we can't do brackets first, so we have to use this law. Okay, so let's try. Oh, hang on, we'll just get rid of the whole lot, I think. Select all. There we go. Okay, so if I have 3 times x plus 5, how do I expand that? Remember our general rule, A, B plus C equals A, B plus A, C. Most importantly, there's an invisible times here. Invisible times, so yes it is 3x plus 3 times 5, which is 15. Okay? Okay? Going back the other way, if you had 3x plus 15, you would notice what's the highest common factor? That's 3 times x plus 3 times 5. So 3 is common to both. So x plus 5. There's a nod, that's good. Bell's going down.